In problem 2, we have the same kind of a problem we had in problem 1, where we have a compound inequality where we always want to try to get x, in this case k, by itself by subtracting 3 from all three parts. 15 minus 3 is 12, less than or equal to 4k, which is less than 36, and then dividing all three parts by 4. We see on the left-hand side of the inequality notation, 12 divided by 4 is 3, less than or equal to k, because the 4's cancel. I didn't do that in the last problem there. 4's cancel there, we get k, and then we also get that, so we have k is greater than or equal to 3 and less than 9, and using our graph, so our graphing notation would be we show 3, we show 9, and then we see that k is allowed to be equal to 3, so the graphical representation of our solution would be all the real numbers between 3 and 9, including 3, but not including 9. So basically, if we were to replace k in the original inequality with any number between 3 and 9, it would make that real number would make the inequality a true inequality. All right, problem number 3. We could see we have the OR statements for problems 3 and 4, and with the OR statements, those give us a little bit of a kind of a different look than numbers 1 and 2, but we have two different inequalities we want to solve. We want to add 3 to both sides of this inequality here, and then we get a is greater than 6. A is greater than 6. Or, so all the real numbers that are greater than 6 would make this inequality true. And over here, we're going to go ahead and subtract 5 from both sides, and after doing that, we get negative 7a is greater than 42. And getting a by itself in the second inequality, we see dividing by negative 7, the negative 7's cancel, but don't forget we divided by a negative number, so therefore doing that we have to switch the direction, change the direction of the inequality symbol. So instead of greater than, now we have less than. A is less than. 42 divided by 7 is 6, but 42 divided by negative 7 is negative 6. So we have the solutions to this compound inequality are all the real numbers greater than 6, so to the right of 6, or all the real numbers to the left of less than negative 6. And we show all the real numbers greater than 6 by putting an open circle on 6 and drawing an arrow to the right. That indicates all the real numbers to the right of 6, or all the real numbers to the left of negative 6. One thing I just noticed that I forgot is the interval notation on problem number 2. But we'll do the interval notation here. Remember, from the beginning of time all the way till negative 6, from the beginning of time all the way to negative 6, all of those real numbers satisfy the original inequality. So that's what those numbers that are shaded in are represented by using interval notation like that. Or all the real numbers that are greater than 6. In other words, from 6 until the end of time. They just keep going further and further. So we see the inequality notation, we see the graphing notation, and we see the interval notation. So all three of these are parts of your answer. And let's go back to number 2. Number 2, we had all the real numbers between 3 and 9. So we start the interval on the far left side. Intervals are always starting from the far left. All the way to, so all the real numbers between 3 and 9, not including 9, but including 3. So there you go. I think I'll start a new video for number 4.